Okay, previously, so we were considering curves. Curves 中文是啥？曲线。Okay, and we had an interval, for example, 0, 1, right? And we map it into our plane, R2. And it should be smooth. And this thing is called a parametrized curve. Okay? And actually, the real curve is the image of my map. So basically, I have this thing is my curve, and this map tells me at which time, so at t, like if it's between 1 and 0, then I have at t equals a third that I'm here, t equals a half, I'm here, and then t equals 1, I'm here. Okay? So basically, it says I have a road, and this thing tells me how fast I drive through this road. Okay? That's my curve. Now, it's called regular. Okay? If the derivative is non-zero. Oh, I don't need that. For all t. What is the derivative? That's basically how fast I drive through this. So if I go through this, if I stop turning my turning wheel, where in the direction I'm going after time 1. Well, that would be everywhere. This tangent vector here would be my derivative, right? And it's called regular if that thing is never 0. And why are we doing that? Because there was this example where we could have a smooth curve, basically e to the 1 over t squared minus and minus. Which is smooth at t equals 0, and it makes this thing here, and the derivative is always 0. Yeah? So we have, when we are a car, we go here, stop, turn, and go back. And this is a corner we don't want, okay? Because that's, and just for you, that's the same regular as in all these regular homotopy thing, right? Because we want to avoid such a loop to go smaller and go this and then go this way, okay? Okay, because at this point we will have something which can still be smooth, okay? The map can be as smooth, as you like, but then you have this corner in the image. Yeah, you want to avoid. And that's why there's this concept of regular homotopy or all sorts of regular whatever. Even if you want to turn your sphere inside out, regular homotopy really means that, because there's no point of allowing such a point, because you can have a loop and just straighten it if you don't exclude that. Okay? So the next one, so that was the tangent vector. We really wanted this to be non-zero, meaning if I take the length of the thing, so of all my vectors here, that would be my speed. Okay, so the speed I drive through this road, and if it's never 0, then we can always drive through the thing. Yeah. So basically, if you have a curved road, you can drive through this with speed 1. But if you have such a corner, you always have to come to a stop, turn, and go back. Okay? Now, The next one we had was the curvature. Okay? How was that defined?
Curvature.
What is curvature in Chinese?
Theta.
No, what is the name? 曲 what? 曲率 哦曲 弯 okay 曲率 okay. So now if you want to define curvature for your curve, you know, visually, clearly, right, this here is very much curved, while this is less curved, this is straight, yeah? And this should have curvature 0, that's something, but that's very high. And if you go higher and, oh well, that's not higher and higher, like more steep, that should go at some point to infinity, right? Okay. So how to measure curvature? If you are considering this thing as the road, and then the curvature, if you drive at speed 1, would be how much you would turn your the wheel, right? And how much you turn is basically how the direction, which is gamma prime, changes. The change of your direction is your curvature. So definitely the second. And how much it changes normally would be basically a norm of gamma 2 prime, right? And since that has disadvantages, I will tell you later, we can consider this scalar product to be kappa, which is the curvature. Now, what is n? Okay, so if again, let me just draw the picture. I have here a point gamma. This is my gamma prime, which has length 1. Okay, then I rotate 90 degrees, and this thing has length 1 as well, and that is my normal vector. And there's 2 ways to do that. There's a plus n, and there's another normal vector which satisfies the same conditions. So the curvature actually has not, I mean, you need to choose a sign, right? Because if you, now, why is this basically the norm or the length of your gamma 2 prime? Because if gamma prime has length 1, so this thing is just 1, so you can differentiate, yeah? Is 2 gamma 2 prime gamma prime, and because that was 1, this is just 0. This is 1, if you differentiate it's 0, yeah? Right? So with respect to this coordinate system, gamma prime and n, gamma 2 prime just look in normal direction anyway. So the length, so gamma 2 prime is something here, and the length of that vector is basically kappa. Yeah? Now, there are 2 signs. You can have positive kappa or negative kappa. What does it mean? Yeah, but does it? Do you think? Yeah, but does it make a difference whether you look such a curve or such a curve? Why is it positive or negative? Does it make a difference? I mean, I can just rotate. It becomes this one. It's the same curve. What is the difference? So what is the difference between this curve and this curve? Huh? 怎么样子搞这个方向？嗯？ So let me make maybe one example first, okay? Easy one. Gamma of t is just some vector 1, 0 plus t times 1, 1. Okay? What is it?
Segments.
No, I mean, what is the curve first?
Curve is a line segment.
It's a curve function of y equals x
y is x minus 1.
Yeah, so that's my 1, 0, and after time 1, it's at 2, 1, 2, 1. So this is the line. Yeah? Okay? So now let's compute the curvature. Let it make sense. So gamma prime of t is just 1, 1, and gamma 2 prime of t is 0. Yeah, because there's nothing in t here anymore. Okay? So that's one example. The other example would be a circle. Right? So gamma of t equal Can you compute the curvature? Do you think it's what is the problem with 1 over r? From 这个转90度。有个 就 gamma prime， 然后转90度，可以往上转或者往下转，没有定。Why is it 1 over r squared and not 1 over r? So let me compute first, okay? What is gamma prime?
Gamma prime is r minus 90. Yeah. And gamma prime t equals r minus cos 90 minus sin 90.
And now?
So the kappa is that one, but so it should be the angle.
What is n?
It is actually gamma. R. Gamma. Negative sin t plus 90. No. N is R, negative cosine t, negative sin t.
So what is the problem with this n here? And what the gamma prime here? What is the problem? What is the length of gamma prime?
The length of gamma prime is R.
Yeah. But when we defined this one, we needed the speed to be 1, right?
Yeah.
So that's not the proper thing to do. Also, the normal vector must have length 1 by definition, yeah? Because so, how to repair?
Divide by R.
Where?
N.
We can, yes, n we can just divide by r, that's true. But then it doesn't change that the gamma prime has the wrong speed. We go through the curve with speed r instead of speed 1. How do we repair this problem that gamma prime is the wrong speed?
Divide it by R.
Which one do we divide by r?
Divide gamma t by R. Yeah.
I can divide gamma t by r, but then my
Error. The way it's we already have that the formula given yesterday,
And so we can consider gamma t over 2 pi r.
We can slow it. You can slow it by a little bit. Is it like this?
Maybe this.
It's a parametric level.
It should be.
What is the opinion on this?
And 1 over r will be extracted when you take the speed of gamma t.
I think you can use the formula I used yesterday.
Which one? The problem is if you divide the gamma by r, then you have a different curve, right? It's not radius r. So this one need to have the norm of gamma should be r, right? That we need because that's so. Yeah, I mean that's what he's suggesting. Are you okay with this, or do you think it's wrong? Do you think it's correct? So, do we change the curve? Just a question. Do we change the curve? We don't change the curve. Okay?
But we expand the fine.
Yes, we change the domain. Yeah, we change the domain. Instead of 2 pi, we change it to 0 to pi r.
Oh, yes.
Right? That's fine.
Oh. Yeah, that's right.
Yes? Do you have another suggestion, or do you think this is correct? What's your opinion on this? And if you think this is correct or wrong, whatever, give a reason. Yeah, just explain why you think it's correct or not correct.
I think it's correct. Because cosine squared plus sine squared is 1.
Yes. So the length is still r. Okay. So what happens here?
We divide r divided by
What is the? Okay, let's do this. Just tell me what the derivative here would be.
It is r. It is cosine over t sine. Cosine t over t over r sine t and sine t over r.
Huh? That's not that. Did you differentiate? Okay. What is the derivative from here to here?
Negative sine and cosine.
Factor here or no factor?
No.
No factor. Good. So this one now has length 1, right?
But there is something wrong. Gamma prime. Yes, it should
What is then gamma prime prime?
1 over r.
What is this now?
1 over r.
Yes.
Negative cosine t over r and negative sine t over r.
Okay. What about n? What is n?
So okay. And minus cosine. It should be
minus cosine t over sine t over r.
yeah, and sine.
Okay. So, sine. There's a minus there. No, wait. No, cosine, no. There's a minus. Like this. Must be. No, there must be minus. Sorry. It must be 0, yeah.
Yeah.
Okay. What is now?
The angle.
I think there's still some problem somehow. That's strange. I find it strange as well. Let me put it this way. I haven't done the computation myself. There's no computational. There's some.
Okay, it's wrong. Yeah, obviously because the equal, and so cosine of the angle is 1, but times the series before, because we should compute the norm of them, and so.
Okay, there's some. I think it should be r squared, but I'm confused here a little bit. So maybe there's some mistake with the thing. But basically, that's how the computation goes. Yeah. So it's you always reparameterize like this, and then do the. Okay. Let me think about this again. I haven't. Okay. Well, probably it's fine. Okay. I don't see any problem now. It's okay. Okay. So now, how does the curve look like? So how does where's can you draw me the tangent vector? The tangent vector. Tangent vector. And the normal vector. This one and this one. Can you draw me the thing on the circle?会出事儿吗？答错了会出事儿吗？
No.
Do you mean? Yes, but is that the right one? The question is here, right?
The orientation, right?
Yeah. So there's the tangent line here. Now the question is, is the tangent vector in this direction or in that direction?
Oh.
And the normal vector goes in this way or this way?
If you write the cosine of x, it goes like this. Not
What do you
like
think?
this.
Let him answer the question. No, but that was the question. So, in which direction does everything go?那 normal 是往外面，我们写的那个 normal 是外面还是里面的那个呢？ Why?
Because this maybe this t over r here. And cosine t over r is more than 0, but it is have a minus there, so it is less than 0.
Yeah. So the best way to do it actually at t equals 0, right?
Yeah.
So we do that at t equals 0. If t is 0, then what? This is 1, this is 0. So we are at this point, and this is 0, this is 1, so it goes, what? Oh yeah, 0, 1, this. This way, because this is 0, this is 1. And this is minus 1 and 0, so it goes this way. Yeah? Okay, good. So now, if we have the circle in the other direction, how would that be parameterized? So I want a circle, but I won't go this way. Yeah. No, not rotation. I mean, I just want, now, we have now a circle which goes this way, right? I want the circle goes this way.
Okay.
How do you do that?
Go the opposite way.
Yeah.
T goes to cosine to negative sign.
That's also possible. That's true. 2 pi r minus t. 2 pi minus t.
Or cosine to negative sign.
Okay, there's many options, yeah? What is the first one? What do you want?
Cosine t. So you should go from 1 0 1.
It doesn't matter. With the domain doesn't matter. I just want to go this direction instead of this direction.
Okay. Cosine to negative sign.
Does it work? Let's see. So at 0, we still have 1, 0, and the derivative is 0 minus 1. Yeah? Okay. Let's do this. And now, well, by the way, other way to see it is yeah. Why? Because now this thing, you basically map t to minus t. This has a negative derivative. Remember, we defined last time reparameterization, where the derivative is positive is orientation preserving, when the derivative is negative, orientation reversing. So this is doing the job. Okay. Now if we compute the curvature, whatever, then and then.
Cosine of t.
Do you know what the derivative is?
Cosine of t sin.
Yeah, so that's, you know? Okay.
I think that's cosine of t sin.
Cosine t sine t? Or do you think it's minus cosine t sine t? Oh, really?
Really?
Yeah? So you want something that goes inside here, yeah? Okay. Let's compute whether it's good. So the derivative here would be minus k sine t sine t Well, probably you wanted this so that the curvature is
Yeah.
What is the difference? Why did I change the sign of the normal vector? What did I change when I changed it? Yeah, this thing is called exactly the orientation. So we want the tangent vector to be the x-axis, A1, this to be E2. Here, E1 and E2. And if you go here, rotating to the left kind of gives you the map from E1 to E2. So that's orientation to the left. Here is also orientation to the left, right? If I would choose the other vector, then I would rotate to the right instead of to the left. So that's why the normal vector here, in this case, if I go the circle in this direction, needs to be this one, the outer one, and not the inner one. Okay? If that's what we want. And in this case, my kappa would be -1 for r equals 1, while here, my kappa is +1 when r is 1. Yeah? So as you can see, this curvature, although the figure looks the same, can have different signs. Just by how I go through.
Just by taking different as.
First of all, by taking different, just by taking a different spin, different direction, orientation, how to go through the, yeah? If it's an open one, it's easier because you have an A and B. If you go from A to B, it's obviously different when you go from B to A, right? You have a different start and end point. So when I go from A to B, I have positive, negative, positive, and other way is negative, positive. Just switch sign, yeah? Okay? Because left turn, the idea is left turn is positive, right turn. Is that correct? Yes, right? Left turn is positive, right turn is negative. Okay? If you look at the circle, so when I do, what is this, the wheel thing called in English? Steering wheel, good. Thank you. I was looking for that word for now. Okay, the steering wheel, if I put it on the left, to turn it to the left, I have positive curvature of my road, and to the right, I have negative curvature, okay? So it really depends on where I'm looking, because if I turn it around, it will change, okay? So that's the main takeaway today, maybe. So now we have curvature, we have a curve. What do we want to do with it? What are questions that you would ask? What do you want to do with it? Regular homotopy. No, something easier. Not regular homotopy, because you need to introduce for regular homotopy something more object, just with curves and curvature. What can you do with what you have? If you play a game like with these thingies, you just have what you have, and you want to build something with only these sticks and the balls thingy there, right? Nothing else.
How about mappings from one curve to another? Mapping.
You want a mapping from one curve to another, like this? What else? This one is it's basically you can always do, right? Because look, why can you always do that? Because it's defined on AB, the gamma So you just define a map between the intervals, and you have a map on the left, on the right-hand side. Yeah? What else can you do? No, just with curves. As I said, you have a toolbox. You want just to use a toolbox to build something. Let me start with some questions you should ask, or you could ask. For example.
Oh, I got it. For example, I think we can prove that. For example, for circles. So.
Let me start with a line. Yeah. So if kappa is 0.
Oh, I got it. I think I have solved it. So maybe.
Wait a sec. Let me just
make the intervals the kappa and by to be 2k pi and k represents the.
wait a sec. Let's just.
How.
Wait a sec.
When I was young, I used a really.
Well, you should not use the phrase "when I was young." Okay, when I was young, it's like, yeah. You should not do that.
Years ago, I used a.
Years ago, so when you were still in your diapers. No, let me just finish one thing. So if kappa is 0, okay, what is it? Must be a segment. Why?你也可以说中文，为什么？
能说中文？
可以啊。
看不懂诗词，看不懂你在写。
啊？
老听不懂你在说什么，但看得懂诗词。
那 ，so 如果我的 curvature 是0的话 ，OK， how do I prove that the only curves with no curvature 0 ，OK， is a line， 就是直线 ，yeah。You need something to write? Very good.他每次都说他年轻的时候做过这个做过那个，
是啊，他现在也不老，
好像不老。对。
继续一说，我早死了。
年轻的时候。
说宫颈当时不已经。
我都还不说呢，我也不说。I don't say that. I never say that.
啊，替人非常高的还是。
哦。
啊，就是说这句话适合那种留着一堆胡子的。
对，至少。你至少得退休了以后才说吧，这种话。 没事。
退休之后不都60多了？
对啊，那个时候就可以说我年轻的时候做了什么呀？之前好像有点。
然后我觉得真的有人能熬到退休。
Many people.
The angle that write it down.
Sure.
Suppose image of gamma is homomorphism to S2. Then
Well, how can it be S2?
what was it? This is the circle.
But the image of gamma is just a curve. It's one-dimensional. It cannot be
Yeah.
two-dimensional.
Yeah. And then the kappa E L. This is just a 2 pi. So for example,
Yes, that's for the.
and the kappa is maybe is it correct?
You can do, yeah, and then.
Yeah. Exactly. And so if you add those angles, it will totally.
Yes, why? The question is why, right? You can add the angles, sure. You can do, but why?
So we have got the angle in N and gamma from
再说一次。
That this zeta between N and gamma prime.
Yes.
It is not equal pi over.
There's no angle actually between n and gamma prime. It's the same, yeah.
Yes. So this is 1. Because there is in a line.
Yes.
And we have that this gamma prime and N actually it is equals that.
Yes.
But we have that zeta equals 0, so we can. This is 1, and we will let go of this. And this is
I mean, this is just the length plus minus. Can I? You do have sometimes negative kappas, but this is positive, right? We showed before that this can be positive or negative.
Yeah, but we have that this is 0, so we can know that gamma prime.
No, it could be a pi as well, right? I mean, but don't need to be this way. It could be.
Oh yes,
This
I
way.
think it should be positive or minus a negative a 2 pi.
Right? Well, but you have to show it, right? So why? This is not
the
an.
absolute value is 2. Not,
Yeah, but this is not an argument yet.
Yeah.
So maybe for that argument, you should think about this problem. Okay? It's basically for this argument, why this should be true. You need to think about this argument first. Given a kappa, okay, how do I get to my curve? Maybe not exactly this one. So it's the easiest question is here, right? That's the first case you should consider. But the general question here, when you give me a kappa, how do I get the curve?
So kappa of t.
Yes, sure. So maybe also for those, just try this one. Just try this one. It's a worthy exercise, yeah? Given kappa equals 0, how do I show that the curve must be a line?
So I think you also need to give gamma. If kappa is 0 and 1, You also need to give gamma 0 or gamma 1.
But it doesn't change whether it's a line or not, right? Does it?
Yes. Maybe. Okay. So.
Do you know what a derivative is? Let me explain that to you first, okay? So when you have a function, some interval, that's okay? 2r, right? Then you can draw this thing, right? Like this, that's your graph. And now, when you have, it's too small. Let me put b here. And let me to t1 and t2. Okay? So this corresponds, to these 2 points. Yeah? And the difference is a straight line, like this. Okay? Now, just imagine your T2 goes to T1. Yeah? Okay, but you do this straight line. Maybe I just draw a different, do I want to draw it differently? So like this. So this would be the first approximate of your derivative at T1. Okay, this vector you would call this way. But then, of course, you have the T2, which was here on this way. Now, if you do move your T2 to here, for example, right? Then you will get a second possible vector, which you could call f prime of T1, right? Now let me draw a picture that is more, not all the lines are on top of each other. That's my T1, okay? And these are my first my T2. Here, T2 tilde, like this. And eventually, when T2 moves closer and closer to this point, we will have a line which is tangent to this thing. Okay? Before, even you have a circle, if you have a circle, you have this point, your thing is going to look like this way. And if it moves all the way up to T1, where you actually cannot define it anymore, your vector becomes tangent. Okay? You would always divide, the length of that vector is this thing divided by T2 minus T1, so that it's kind of normal. So you cannot, it's not getting shorter and shorter. Okay? So this thing in the limit is called f prime at this point. So basically, it's the vector that is tangent to this point of a certain length. Yeah? So when you want to, if that would be a curve, right, a road, and you drive through, basically it tells me when I drive through the thing with speed 1, and at this point I don't change my steering wheel anymore, and after time 1, so I don't change anymore, after time 1, where will I be? Right? It will be here somewhere, and this would be the length of the thing.
Teacher, for circles radius r, what is the curvature of, is that 1 over r or 1 over r squared?
I mean, the computation shows I 1 over r. I would have guessed it was 1 over r squared, but that might be just wrong, and it's just 1 over r.
So it should be
1 over r, I think so.
Okay, so is the answer?
I believe the computation more. So basically, so the length is that. So it's kind of the thing that's tangent to the thing. Okay? Now, whenever you say, I want the rate of change of something, that you can always replace with derivative, because that's exactly what this is about. I want to know how my curve, or how my function changes from t1 to t2, right? And if the t2 is very, very close, that's exactly the rate of change I have at this point. Yeah. So that's why whenever you say something like that, like, what is the rate of change of my steering wheel? That, and my steering wheel, if I'm driving with some speed, is already, as I said, if I don't change it anymore, I will just leave the road and move here. If I now change the thing, I want to know how this point will change, right? So that's differentiation of my gamma prime. Okay. Now all these other things are just formulas, right? It doesn't really matter. But this is basically the idea. I want to know how a function changes. Yeah.
So given kappa, can I write my answer to the threshold?
Yeah, sure.
I'm not really calculating.
I just erase this one, I guess.
So suppose gamma prime. Suppose gamma prime is 1. Or given kappa. So we think for example, this is a curve, and at this point P, a kappa is it's just like it locally looks like this is a circle.
Yes.
And so the kappa P is R, and kappa P is 1 over R. RP.
Yes.
Yeah. So we can use this property. Okay. So these angle to be theta p, okay? Or gamma t. So this will be theta t.
Yes.
And so because it's locally the same, so we should just take this circle, and for given for delta, so this is theta t delta t dt, or like that.
If you want to, yes.
So I think we can add gamma t. It could be maybe this 0 to t. The radius is 1 over the kappa t. So what's that? Kappa x, and cosine of theta x.
What happened with kappa 0? Then you cannot integrate.
As the x dx.
What happens with kappa 0?
Yeah. Yeah.
No, well, first, what is gamma prime of t?
What?
What is gamma prime of t?
Okay, I can prove that kappa equals 0 implies the curve must be a
Wait a sec, let him finish.
I need to.
You need to prove. Okay. What? Wait a sec. What is your?
I think I have some like strange thoughts about it. Because of
Which part?
it is because kappa equals 0 and we have that.
Okay.
It must be a segment. Is it because that actually
Let
we
him-
could solve that this kappa equals 0 and we have that 就是半径为 r 的圆，然后这个 kappa 是 r1/3，然后我就觉得它可能是就是取这个 kappa 趋近于0，然后它的这半径就会就是可以理解成它的半径就会越来越大，然后它等于就可以理解成半径无穷大。
可是我们也不知道这个 kappa 是个 constant， 是个 circle， 是个圆形吗？
I can prove that.
Okay. Yes. Wait a sec. Let him.
Okay.
Yeah. This is okay.
I can prove the case that kappa equals 0. I'm just letting in gamma t equals xt and yt. Because I'm good at 一流子学来着好像是什么？Single variable. Because I'm good at single variable calculus. Okay.
Good.
And I want to write it as this. Okay. And so gamma prime t, gamma double prime t is x double prime t, y double prime t,
Yes.
and t equals negative y, I prime t, x prime t.
Yes.
Okay, so kappa equals negative y prime t x prime prime t plus x prime t y prime prime t. Notice that. Notice that x. Oh no. Y prime t over x prime. The derivative of y prime t over x prime t equals to x double prime. Oh no. X prime t squared. As the denominator and the numerator is y double prime t x prime t minus x double prime t y prime t. It equals to 0. So y prime t equals to c times x prime t. And we also have y prime t squared equals x prime t squared. Oh, plus x prime t squared equals 1. And they can they change? And they cannot suddenly change. That is that the y prime t and x prime t must be continuous. So we have x prime squared t equals to positive and negative 1 plus c squared. No. Let me check. And maybe we can. Okay. X prime t equals to and y prime t. That is it. So
There's
x
some.
prime t and y prime t are all constants. So this must be gamma c must be a segment or a line.
Okay, one thing. This one, the denominator here is this kappa, yeah, which is 0. Right? So that's why this is 0. Yeah? And y over x is basically
So
that's
y over
the-
x is a constant.
And it's constant, and that's the theta. That's what he computed here. So basically that angle, which is where is gamma, is constant. So it can only be a line. Another way to do it. Can I just erase this? Okay. Another way to do it. Okay, which is maybe less computative or computing heavy, is the following. So I know I want to find a curve which has unit speed. Yeah. So my gamma prime definitely is like that. So let's write it as cosine. Well, I think you preferred theta, right? Like that I can always write. Right? Is that correct? This is unit length. And kappa equals 0 means that gamma 2 prime is 0. Because gamma 2 prime n, that was parallel, n is not 0. Yeah. At least this is equal to, and that must be 0.
Oh, yeah. Clever.
Yeah?
Oh, very clever.
But what is gamma 2 prime? That is theta prime, whatever is up there. Right? So it can only be 0 if theta prime is 0, because this part is not 0. Yeah? So theta is constant. So gamma prime is constant. So gamma must be, can only be linear, yeah? Well, basically gamma can only be some AB plus T times gamma prime. Okay? So now, when we are here, let's try to find a curve for every kappa.
Okay. So is that a formula correct? Given?
Huh?
So is that a formula given by me correct?
No. Because, I mean, as you can see, you couldn't do, I mean, first of all, if you differentiated your formula, you get some gamma prime, which is not unit length or unit speed, right? So you have to do something to compute the kappa, which is complicated.
So the gamma should be unit speed?
It's better. It's easier. If gamma is not unit speed, how do you want to compute the kappa? You have to reparameterize to start with. How do you do that?
Okay. I got it.
Do you know the sine and cosine?
Yes.
No? So you have a circle, okay? And you have this point here on the circle, right? This is an angle alpha. Now, this thing is called this value is sine alpha, or other way around. Yeah. Okay. So you have some special values. If alpha is 0, you can see cosine is 1 because that's minus 1. Alpha sine also alpha is 0. Cosine alpha is 1. Sine alpha is 0. If you have alpha is 90 degrees, it's the other way around, right? Now, what happens if you have 45 degrees? So what is
We already learned
yeah, you.
all of them.
Yeah, but me, I didn't. Just think about that problem. I explained how cosine and sine. So what happens for 45 degrees? Huh? In a sense, because this length is definitely the same as this length, right? But we need to, because this is always 90 degrees, we can use Pythagoras theorem. So this is A, this is A. The question is, I know that A squared plus A squared is 1 because the length here is 1. So 2A squared equals 1. A squared equals a half. So like this. Okay. So we don't have a negative because we know this is a positive length. Okay. So this is so in this case we have cosine alpha equals sine alpha equals like that. Okay. And that's basically it. I mean, okay, there's 30 degrees probably you can learn. And that's basically it. You cannot have far more. You have to sine and cosine. So the thing you need to know is that these are the functions. So these are the functions, the length of the coordinates of your point on the circle. I just learned the first one is cosine, that second one is sine. And I think this property, I cannot distinguish them. The only property I remember is this one, and then I get from this, start from that. Okay, so it's just the length of these segments here on the circle, the x-axis and the height. Okay. So automatically, when you do that, it will be length 1. Good. So you have a solution to this problem here? Giving a kappa, how to get the gamma? Start from here.
So we can first get a circle.
No, it's not a circle. Gamma prime is must lie on the circle, right?
我们曾经讲过那个一个圆，它这个卡帕它不是那个radius one over the circle's radius. So we have kappa. We can know first is gamma is a circle with the radius of 1 over kappa.
对，
Yes.
这个数会变化，它并不是元素本身中。它在这圆上可以乱动啊，可以在圆上乱动。OK。Kappa equals to gamma double prime, and that is.
No, not quite. No.
Okay. Nothing.
It's almost correct, but yeah.
Okay. it is gamma double prime equals to theta prime e sine theta t e theta prime t cosine theta t.
What is n?
And n equals to negative sine theta t cosine theta t. Okay, so it equals to it equals to theta prime t
Equals
okay,
kappa.
and theta t equals to
Yes.
theta t is this.
So you have gamma prime. Very good.
So what do you mean?
Gamma is just
Are these the only solutions?
yes. Maybe yes.
Really? What is on this the boundary here?
Yes. How is
This is
this obtained? It is obtained by plug this into
sure. But the question is, what is on here on the boundaries?
boundaries. It's something something plus c. Okay, and
Yes, that's the first. What is
that's your
it?
choice.
It's a choice. That's first choice. What's the second choice?
Each indefinite integral gives us a choice. So,
But still, what is on the boundary? You normally integrate from A to B. A to B, right? What is on the
0 from t.
Yeah, okay, better. Okay,
That is,
good. So every integral gives me now, let me just rewrite the thing, just that everything is in a clearer order. This is correct. So if we start from here, we know that kappa equals theta prime. From this, we get theta is integral kappa 0 t. Let's call it s ds. And gamma equals c0. And gamma equals zero t, and then I have some other variable st. Give me some variable name phi. I should have used pi here. I, B, C, D, E, F, G.
you can just use T0, T1, T2.
Yeah, but T0 is a constant. You cannot do that. Okay, I use T1. T1 is fine. T0 is bad, but the T1 is fine.
T0 is just like a constant.
I know, but it's I prefer not to use T0 as a constant, as the integration thingy. Okay, so now the question is, we have these constants here. What are they? So we get a curve, great. But what are these constants? And that's the last question for the class, and then we check college.
Plug in
What?
the starting point and the ending point. Plug the starting point or the ending point into our gamma.
Why is starting point and ending point?
Because if it's C0 is just like a theta 0, and so it implies for example gamma consists that then if you rotate it, it also consists.
So, what is this referring to geometrically?
How
起点
no
No.
C1 and C2.
Which one is 起点位置
C1 and C2.
Why? Because if I have t1 equals 0, then this integral is all 0. Okay? This integral is also 0. So the only point I have is c1, c2. Yeah? Okay. So what is t0?
C0 refers the angle to rotate.
Yes, exactly. So this corresponds to initial direction. So what I need to give is I give you where to start and where I look at the very beginning, and then kappa does the rest. Okay? And I can rotate. So basically what it says, I can rotate the curve. It will not change my kappa. I can start at some other point. It will not change my kappa as well. Okay. From here, let's go back to the initial question we had. I will ending very soon. Initial question was, what is the condition on kappa to get a closed curve? For that, we need gamma of A equals gamma of B, right? And gamma prime of A equals gamma prime of B. And let's, because it's, well, just, yeah, like this. So what would be the condition on my kappa so that I get a closed curve? If we already have these formulas.哦，是的。冲一下。That's one option. Yes. What else? So that could happen. Yeah. That's a. That's one possible condition. Maybe it's too restrictive. It's maybe too restrictive. How can we relax that condition a little bit?
Or too high.
Or why? I mean, okay. 2 pi. What else?
Or 2k pi.
2k pi.
So for K.
K. Like that. Why? If you have these formulas, why?
Yeah. Is it that?
Yes.
Okay.
But
We have the two conditions. 0 to 1 cosine of 0 to t. This is supposed
no, just use.
gamma
Uh-huh.
0 1 like that. Or
Yeah, but the cos there's brackets here.
yeah, I know.
Oh, sorry.
I know. dt equals 0, and also this.
Mhm.
Yeah. dt 0.
I mean, that's not enough. But but what? How do you? That's one condition, yes. And what else?
And also,
Yeah, we had this one, yeah.
yeah. So the bit for so this derivative
Let me think again. Good. Dad, you're tired, right? You look so tired. Falling asleep.
Oh, okay.
Falling asleep. It's too late. I know, and we should stop. We should stop. Do you want to work on this thing and we talk about it next time, or shall I give you the answer?
Okay.
Next time or answer? Next time. Okay. Just think about it next.
No. Let this
Exercise. Okay. 下课。